Okay, so we're going to do waves today, so I'm going to head over to the resource bank. And I'll just pause the video so we can find some simulations. So I've got a load of different simulations open up, and all these have been added to your resource bank. So you can always access all of my resources anyway, but if you go to your page, you should find them in the area that's just called My Resources. So let's start off with wave on a string. This is the best way to. This is the best one for introducing waves, I think. So what I'll do is start off. I'll just press pause on the simulation, change that to oscillate, choose no end, turn the damping down. That's what you want to do when you play around with it. And if we press play, you'll see it makes a wave. Now, if I put it in slow motion, and if you notice, if we pick any one, if we look at any part of this wave, like especially the green circles, we see the green circles are actually only going up and down, which is surprising because a lot of the time people think that something seems to be going from left to right, and something is going from left to right. So we might want to try to identify what is it that's going from left to right. If it's not the particles, what is it that's actually moving from left to right? So what do you think? How would you describe what's moving from left to right? So the thing that's actually moving from left to right, well, we could say a couple of things are moving from left to right. One one thing that's moving from left to right is the energy. So energy is moving from left to right. But another very important thing to think about what's moving from left to right is information. So because what we're seeing here that's moving from left to right is a shape. We're seeing this shape that's moving from all the way. I can follow it, and there's another one, or I can follow the bottom one. So the thing that's moving from left to right is this shape, and that shape can contain information. So, for example, I could start off. I could change the frequency, and when I change the frequency, it goes really high pitched. If I do that and then click restart, then press play. If I'm standing over here, I may not know what's happening, but eventually the information of the frequency will come to me. And now I can see, I can measure that frequency, and I can see what the frequency was over there. So we'll talk about what frequency means in a moment, but for now you can basically see that frequency seems to be, well, I can briefly explain it now. It's how often this thing is moving up and down. And if you look at any one of these circles, the green circles are easiest to see. It's how often each circle is moving up and down as well. So maybe we can start off by defining that, in fact. So the frequency is equal to the waves per second. But you could also measure it as, or the oscillations per second. We'll talk about what oscillations mean in a moment. Oscillations per second. Okay, so an oscillation is just it's just a forward and backward movement, or an up and down movement. Up and down, that's an oscillation. But if it went forwards and backwards, that would also be an oscillation. You also get it like on a pendulum. Pendulum goes back and then forwards again, like that. So that would be an oscillation. Okay. Now, what you'll notice about this type of wave is that the oscillation is up and down, but the movement of energy, we can also call this the wave propagation. So direction of the wave. The wave propagation is at right angles to the actual oscillation. I'm just going to see how much. We've got 27 seconds left, so we'll stop that video there, and I will make another one to add to it. But that one was just covering frequency, what frequency is, and looking at what's moving from left to right, and seeing that this type of oscillation is moving up and down. I'll briefly say now that this type of wave is called a transverse wave. Okay, all right.